Now let us see what segmentation is about in the memory management. Segmentation is a memory management scheme that supports the user view of the memory. It's a memory management scheme that divides a process into logical segments. Here, each logical segment represents a meaningful unit of a program. Need not be of fixed size blocks like we used in paging. So each segment has a base address, that is where that segment begins in the physical memory, and what is the length of that segment, what is the limit up to which the segment can expand. So why do we require segmentation in the first place? So usually the programs are naturally divided into different parts like the code. Usually the code is a text segment where the program instructions are written. Then we do have a segment reserved for the data. Usually the global data or the static variables are stored in this part of the memory. And we have a stack that is used to store the local variables, the temporary data whenever we go on function calls and all that. So when we have to call a function, at that time we have to stop the current process, whatever it was doing, and switch the context to the function. Once the function execution is done, we should continue, resume where we had stopped. So to make sure that we resume the previous process where we had stopped, we need to remember the whole environment at the time of context switching, at the time of shifting the CPU time from the current process to any other function. We need to store the environment. The environment usually consists of the value of the program counter, that's the next instruction to be executed in the code, and then the various contents of various registers of the processor at that instant, which register consists of what value and all that. That whole thing has to be remembered so that when we come back we need to begin from that situation. So we need to remember that, and then we need to remember the values of different variables which we were using and all that. So for all that we need stack. So for local variables, for function calls and all that, stack is required. So some part of the memory is reserved for the stack in the process, and then we do require a heap memory that's usually used for dynamic memory used when we are creating the memory for dynamic data, that is the size of the data. If it is not fixed, we want to keep changing the size of the memory defined for that particular data, and that can be easily done using a heap memory. So these segments map the logical structure directly into the main memory. So segmentation is a process that maps all these logical structures onto the main memory. So logically, if you look at that from the user's perspective, we can just say that this whole boundary is about a particular process, and that particular process consists of many segments like a main program, symbol table, stack, subroutines. So maybe one function called square root and all that. So these are the different uh, logical segments we have in our process, and this is how a user views it. So whenever we are working with segmentation, so we do use the hardware, segmentation hardware for defining and locating our address in the physical memory where exactly we are looking into. So each component is called a segment. So the segment is given with the base address, and then we have for every segment we have a limit and its base. So we just look at where the base begins, and the displacement talks about in that block at what place the current data is available, or current location we are interested in is available, and all that is given by D. And just first verify whether it is less than our limit or not. That means it should be within the allocated memory for that particular segment. So if it is within that allocated, then yes, then we give the base, add the base to the displacement, and then we get the actual address of the main memory. If it exceeds the limit, that means that we are trying to work with some other data, or outside the limits we are looking. Therefore it should call for an alarm, and that alarm is a trap, and says that there is an addressing error and all that. So that's how the segmentation is used. So as an example, if you just look at it, this is how the logical view is. But in reality, if you look at that in the physical memory at different places, the different parts of the process are situated. So segment 0 is situated here, segment 3 is situated here, segment 2 is situated here, 4 is situated here, 1 is situated here. What are they? So segment 1 is our sqrt function, segment 2 is the main program, segment 4 is the symbol table, segment 3 is the stack, segment 0 is our subroutine and all that. So wherever memory was available, these segments were put on that, and then we create a symbol table saying that where that particular thing, segment 0, where is it? It is from 1400 and it goes up to 2400. That means 1000 is the limit. Then segment 1 is starting from 6300, goes up to 6700. That means 400 is the limit, and so on. So this is how we visualize the code, as that they are different chunks, but in reality they are actually stored onto the memory at different locations, and our segment table will help us to identify which part of the memory our segment is situated. And once that segment base address is known, then the displacement can be added to that to exactly pinpoint which address we are talking all about. So that's about the segmentation. Other details, many more issues regarding memory management are in reserve on the way. So keep watching. Thank you. If you find these videos useful, don't forget to like, comment, subscribe, and share with your friends. Thank you.